This is Davika Academy. Today we want to look at Bosano-Weirstrass theorem. Bosano-Weirstrass theorem is a very key theorem in real analysis, so kindly make sure you understand every bit of this. Subscribe if you have not subscribed to this channel, and also remember to share with your friends. So let us look at Bosano-Weirstrass theorem. It states that every bounded sequence has a limit point. Every bounded sequence has a limit point. That is Bosano-Weirstrass theorem. Let's prove this. We have to let S to be that sequence, and this that sequence, and is actually the range of the bounded set Xn, sequence Xn. Since the sequence is bounded now, this will mean also the range is also bounded, and therefore we expect S, and therefore S will have which is the range, will have finite or infinite set, will be either finite or infinite set depending on the sequence. So you suppose that the range S is finite. Then if it's finite, it means that there exists at least one member P of S such that Xn is equal to P for n infinite number of values of n. This will imply that for every neighborhood of P, contains a Xn which is equal to P for infinite number of P. We should imply that P is a limit point in the sequence. We should imply that P is a limit point of the sequence. Again, if we suppose that the range is infinite, an infinite set, it will imply that the range, being an infinite bounded set, has a limit point P. This arises from a theorem we call Bosano-Weirstrass theorem for sets, which states that every infinite bounded set has a limit point. Therefore, because S is infinite bounded set, it will imply that it has a limit point by Bosano-Weirstrass theorem for sets. We should imply that the neighborhood of P for a positive epsilon contains infinite number of S, and we should imply that Xn is in the neighborhood of P for infinite number of values of n, and that implies constantly that P have to be the limit point of the sequence Xn, has to be the limit point of the sequence Xn. Okay, remember, if you have not subscribed to this channel, kindly subscribe and also share with your friends so that they can get to get this knowledge about real analysis, about Bosano-Weirstrass. Now let's look at some of the definition about limit points. We have two types of limit point. One is upper and the other one is lower limit point. So the greatest limit point of a bounded sequence is called upper limit, or what we call limit superior. And we basically denote this with limit bar, limit of Xn bar, upper bar. The lower limit point of bounded sequence is called lower limit or limit inferior, and we underline limit underbar, limit Xn underbar. We should mean that limit of Xn is less or equal to this. So the limit inferior is less or equal to the limit superior, which will imply that the limit inferior and limit superior give us same answer, which is L, which is the limit. And if you find L is in this case real number. Remember, we are dealing with real analysis, so expect everything to be real numbers, the solutions. Okay, so limit of a sequence. Let's see and define the limit of a sequence. So a sequence xn is said to have a limit x if for all a given positive epsilon there exists a positive integer, which we call n, which depends on a given epsilon, such that xn minus x is less than epsilon for n greater than the n, which depends on the epsilon. It will imply that the limit will be defined as that, or as xn tends to x, tends to x as n tends to infinite. That the series tends to x as n tends to x, the infinite. So if a limit xn exists, then we say that the sequence is convergent sequence. And if it happens it does not the limit does not exist, then we say that it is divergent. It's a divergent sequence. So kindly subscribe if you have not yet subscribed to the channel. Share also with your friends. Okay, let's look at an example. Show that this one is equal to that for all n in that. So just to show this, we just need to show the divination of a limit, and it happens that it exists if there, just need to show that there exists an integer, which is a positive integer, of course, n, which depends on epsilon, such that this one is true. So if you solve this, you'll find n is greater or equal to this, so that we let this one to be now the epsilon, which depends on the n, which depends on the epsilon, and that will imply that this is true. And therefore this particular example here, it has a limit point and is actually convergent. So it will mean that this half is actually the limit point of this equation. So if you have a question on this, kindly leave a comment. If you have more questions on this, or a question that you need to me to work on it, just leave a comment, and the question is a comment, I'll be able to look at it and be back to you. Okay, so that is it. Kindly subscribe and share with your friends.